In 9.5, we're going to learn how to solve quadratic equations by completing a square. So given the expression x squared plus bx, we're going to take the half of b to form b over 2. And then we're going to square b over 2. So that would be taking b over 2 and squaring it. And then we're going to add b over 2 squared to the expression x squared plus bx to form a perfect square trinomial. So hence completing the square, the name. So therefore, we can write this as x plus b over 2 squared. Okay, to complete the square, find the value of c that makes x squared plus 5x plus c a perfect square trinomial. So to apply the method I just showed you, I'm going to take the half of 5, which is 5 over 2. I'm going to square it. And I'm going to write it as a squared binomial, x plus 5 over 2 squared. And to solve a quadratic equation using completing a square, you can leave your answer in simplest radical form. So first, I can simplify the coefficients and the constant. This will make x squared plus 10x minus 4 equal to 0. Next step, I'm going to move the 4 over. And then I'm going to take half of 10, which is 5, and square it. So that would be plus 5 squared. So whatever I do to one side of the equation, I need to do to the other side. Plus 5 squared on the other side. So on the left-hand side, this would be x plus 5 squared. And this will be 29. And then I can square both sides. So x would equal to negative 5 plus or minus square root of 29. Okay, let's look at some practice problems. Remember, before we complete the square, we need to make sure that the leading coefficient is always 1. So in this first example here, we don't have to worry about it. In my next step, I will first move 5 over 4 over to the left-hand side. So I need to change the sign. Now I'm ready to complete the square. Now, I need to take 3 and I need to divide that by 2. So that would be 3 over 2. And then I'm going to square it and add it to m squared plus 3m. Now to balance this quadratic equation, I need to add 3 over 2 squared on the right hand side as well. In the next step, I can write this perfect square trinomial as m plus 3 over 2 squared. And I can simplify the right hand side. I'm now ready to take the square of both sides. So m plus 3 over 2, where you go to positive negative 1. So you have two answers. So negative 3 minus 2 is negative 5 over 2. Negative 3 plus 2 is negative 1 over 2. Okay, now let's look at this second example. Our leading coefficient is not 1, so we need to try to make it 1 by simplifying the quadratic equation. That's one way, because I noticed that I have all even numbers here. So I can rewrite the quadratic equation as x squared plus 12x plus 5. And now I'm going to move the 5 over to the right hand side, so it becomes negative 5. And now I'm ready to complete the square. So I'll take 12 divided by 2, which is 6, and I'm going to square that. I'm going to also add it to the right hand side to balance the quadratic equation. Now I can rewrite the left hand side as a squared binomial. I'm ready to square both sides. So x equals negative 6 positive negative square root of 31. Now if you look at this third example here, can't really simplify the quadratic equation, so maybe I need to factor out the 3. (20 over 3). My goal is to make the leading coefficient 1. So now I can divide 3 to both sides. This will equal to 0. Now I'm ready to move negative 20 over 3 to the right hand side. And I'm going to complete the square now. Now notice that this is negative 6. So I'm going to take negative 6 divided by 2, which is negative 3. I'm going to square that. Now even though this is negative, it's still going to produce a positive 9. So when I write the binomial squared, I will have to do w minus 3 squared. So this will be 9, and I can rewrite this as 27 divided by 3, which is still 9, so I can add this. Then I'm ready to square both sides. My w will be equal to 3 plus or minus square root of 47 over 3. Now, we have a fraction inside of the square root, so we need to simplify this. So square root of 47 times square root of 3 will be square root of 141 over 3. Now, it's okay to leave your answer like this, but it would be better if you were to combine all of this. In the Algebra 2 textbook, they want you to leave the answer like this, but I will accept this as well. Now let's look at a fourth example. Now this is not written in quadratic standard form, so we're going to have to change things around a little bit. So here's m squared, 7m squared. So I could write 6m squared. And then plus 24m. And I have minus 2 here, so I can move that over to be plus 2. So we have negative 7. Now, this is not in leading coefficient of 1. So maybe I need to factor out the 6. and then divide 6 to both sides. Now I'm ready to complete the square. Take half of 4, which is 2, so 2 squared, and another 2 squared on the other side. So this would be 4, and I could rewrite this as 24 over 6, which is still 4. This will be 17 over 6, and we're ready to square both sides. Now I need to simplify this even more, because we cannot have a fraction under the square root sign. This would be 102 over 6. So that's one of your answers, or you could write this as negative 12 plus or minus square root of 102 over 6. Now, this fifth example here is also not in quadratic standard form, so I need to change these terms around a little bit. So I'm going to subtract 0.9 g squared from g squared, and that will be 0.1 g squared. I have positive g on the right hand side, then I need to subtract that to 2g, so that would be 1g. And then I can move this over, so this would be negative 0.4. Now, my leading coefficient here is not 1. So I can employ a technique by multiplying by 10, or distribute 10 to every single term. This would be g squared plus 10g equals negative 4. Now, I'm ready to complete the square. Now this will be in simplest radical form because there's no perfect square factor for 21. Now for this one we will do the same thing. I'll rewrite this in quadratic standard form. So I need to move negative 9z squared over to the left hand side, so I'll have to add. This will be 20z squared, and then we have minus 10z. Well, I'm going to skip some steps and then just add 3 to both sides. So 3, I can rewrite that as 12 over 4. This will be 15 over 4. Now, 20, the leading coefficient right now is 20, and we want a 1. So we can factor out the 20 on the left-hand side. And notice that this has become half. Be careful. And then I can divide 20 to both sides. So this would be 1 times 1 over 20, and I can simplify this. So this would be z squared minus half z equal to 3 over 16. Now I'm ready to complete the square. Okay, this is negative half here. So I'm going to add negative half divide by 2, which is negative 1/4 squared. So this would be z minus 1/4 squared. So this would be 4/16. And then could square both sides. And they happen to be perfect squares in both the numerator and the denominator. So this would be half. And then I will have two answers. So I could change this to 2/4. Maybe I should have simplified in the beginning. 1 plus 2, 3/4. 1 minus 2, negative 1/4. This is a 1. Okay, now let's look at two challenge practice problems. The product of two consecutive negative integers is 210. Find the integers. Now I'm going to let the first integer be negative x, and the next consecutive negative integer to be negative x plus 1. And their products is 210. And I'm going to distribute negative x into the binomial negative x plus 1. So negative x times negative x is positive x squared. Negative x times positive 1 is negative x. Okay, now I'm ready to complete the square. So the square root of 841, its perfect square, is 29. And then the denominator will be 2. So x will be half plus or minus 29/2. And we have two solutions here. 1 minus 29 makes negative 28 divided by 2, negative 14. 1 plus 29, 30, 32 divided by 2, 15. Now, we cannot use one of these here. Remember I said negative x was one of my negative integers. If I use negative 14 and substitute it in for negative x, I would get a positive number. So, but we only want negative integers, so we don't use negative 14. So let's substitute 15 in for x. So this would be negative 15. And then negative x plus 1 would be negative 14. So my two consecutive negative integers will be negative 15 and negative 14. The product of two consecutive positive even integers is 288. Remember, consecutive means one number after another right next to each other, okay? So we want them to be positive. So we can say the first even integer will be 2x. The second even integer will be 2x plus 2. And product again is equal to 288. Now let's first simplify 2. So this will be 2x squared plus 2x, which equals to 144. Now we can keep simplifying. Now we're ready to complete the square. So x plus half equals 289/4. Now we square root this. So x plus half equals positive, negative, and then perfect square 289, 17 over 2. X equals negative half plus or minus 17 over 2. And we have two answers, negative 1 minus 17, negative 18 over 2, negative 9. Negative 1 plus 17 will be positive 16 divided by 2 is 8. And we're only interested in positive even integers, so we could ignore the negative 9. So our first even integer will be 2 times 8, which is 16. And our second one will be 2 times 8 plus 2, 16 plus 2 will be 18. Okay, now let's practice a geometry problem. Find the value of x, which is the height. So the area of the triangle is given 108. So half times the base of x plus 6 times the height of x equals 108. Now we can multiply both sides by 2. Distribute the x. So x squared plus 6x equals 216. And now we can complete the square. So add 3 squared, or 9, to both sides. This would be 225. Square root. So this will be equal to either negative 18 or 12, but no such thing as a negative length, so the answer is 12 meters. Okay, word problem. You are knitting a rectangular scarf. The pattern you have created will result in a scarf that has a length of 60 inches and a width of 4 inches. So 60 by 4. However, you happen to have enough yarn to cover an area of 480 square inches. You decide to increase the dimensions of the scarf so that all your yarn will be used. If the increase in the length is 10 times the increase in the width, so this is a key sentence here, what will the dimensions of the scarf be? So we're going to increase this by 10 times the width, so plus 10W. And we're going to increase the width, so plus X, or W, excuse me. So, and after doing that, this will cover an area of 480 square inches. And we're ready to set up our quadratic equation. 60 plus 10W, 4 plus W, will equal to 480. Okay, we can use the FOIL method. 240, 60W plus 40W gives you 100W. And then we have 10W squared equals 480. Now we can simplify, and then we can rewrite this as W squared plus 10W plus 24 equals 48. And then I can write this as W squared plus 10W, subtract 24 on the other side, and then to complete the square. Square both sides. So W plus 5 equals positive negative 7. W equals negative 5 plus or minus 7. You have negative 12 or 2. Well, we're not interested in the negative length, so we're going to use 2. So W will equal to 2, and what are the dimensions? So 60 plus 10 times 2. 10 times 20 plus 60, 80 inches for the length. And then 4 plus 2, 6 inches for the width. So this is the width, this is the length. Okay, we're going to look at some additional material here. In 9.2, I gave you a formula to find the axis of symmetry. X equals negative b over 2a. And I'm going to prove this now using the idea of completing the square. So now I'm given the standard quadratic form, y equals ax squared plus bx plus c. Let me factor out the a. Now I'm going to complete the square. I'm going to take b over a, and divide by 2. And I'm going to square it. So that would be b over 2a squared plus constant c. Now, because of this, I also need to subtract this. I cannot just add something out of nowhere, so I need to take it away so it can cancel out. So that would be a times this part. So we're given them a times b over 2a squared. Now I'm going to put brackets around this. Now I could write this perfect square trinomial as x plus b over 2a squared plus c minus all of this. And now I can call this a constant k. Now as you can see, this form is very similar to 9.1 y equals ax squared plus c. So if you're given the form y equals x squared, your vertex will be at 0, 0. So here, the vertex will be here when x equals negative b over 2a. That's where we get the formula. Now we can let b over 2a, or rewrite this as x minus b over 2a. And then we can let this be h, and hence the vertex form. Y equals a x minus h squared plus k. This is an extension lesson in your textbook, and you will also learn this in algebra too. But learning this now will help you with graphing quadratic functions faster. So with the vertex form, so recall y equals ax squared, the parent graph, the vertex is at 0, 0. Now if the parabola changes a position and moves h units to the right and k units up, that would be our new vertex. Okay, so h here, remember I told you, is marked by negative b over 2a. Right here, as indicated in the proof earlier. Okay, let's look at some characteristics here of the vertex form of a quadratic function. The vertex would just be read as h, k. And the axis of symmetry would just be x equal to k. And again, when a is greater than 0, your graph will open upward, and when a is less than 0, which is what I'm talking about here, your graph will open downwards. Okay, let's practice graphing a quadratic function in vertex form. So here the vertex will be read as negative 2, 3. Or you could read it as x minus 2, and then we would need a negative 2. Okay, so here, negative 2 and 3. It's your vertex. And now we need to look for the y-intercept. So that's when x is 0. So this would be -4 plus 3, -1. And then an axis of symmetry again is what? At x equals to -2. So we can reflect this y-intercept of -1. So it will be -4, -1. Then we can graph. And now if you're given the quadratic function in standard form, we can rewrite this in vertex form. So plus -3 squared plus 19, and then 2 times -3 squared is 18, so 18, I've added that, so I need to subtract, take away. So then I'll get 1 here. Now I'm ready to graph because I have a vertex of 3, 1. And then my y-intercept will be (0 minus 3 is -3 squared, 9 times 2, 18 plus 1, 19. So somewhere up there. And my x-axis will be at x equal to 3. So if this were 19, just have to reflect this 3 units from the axis of symmetry. Now you can double check the axis of symmetry with the formula x equals -b over 2a. So let's see, -12 over 2, 3. +3. See? Works. The height y in feet of a baseball t seconds after it is hit is given by this function. Find the maximum height of the baseball. Use completing the square to solve. Okay, so here I'm going to take y equals -16 t squared plus 96t plus 3. And I'm going to factor out -16. Okay, and then I'm going to complete the square. -6 divided by 2 is -3. So I'm going to add -3 squared, which is still +9. So -16 times -3 squared, let's look at it on the side, times, so -3 squared is +9. This will make -144. So because I added -144, I need to add 144 to balance this equation. It'll be 147. Now I'm done. At t equal 3 seconds, my maximum height will be 147. Feet. And just to reiterate, the vertex here is at 3, 147. And because this is a baseball following a parabolic path, when it reaches t equals 3 seconds, it will reach a maximum height of 147 feet. And this concludes the lesson.